is given the matrix A, we should find the determinant of the matrix. We should find the inverse of the matrix A, and hence or otherwise we should solve the system of equations. Now let's start with the solution. Let's start with the A part of the question. The A part says find the determinant of the matrix A. So let's write back the matrix A: 2, 1, 2, 3, 1, 2, and 2, 2, 1. So we have to find the determinant of this matrix. So to find the determinant of this matrix, it is not a 2 by 2 matrix. So we cannot do the normal method. So here we are going to do the cofactor expansion. So let's choose our row. So let me choose the first row and we write our signs. This is plus, minus, plus, minus, plus, minus, plus, minus, plus, telling us which number will have which sign. So I'm choosing the first row. You can choose any row of your choice. So let's start with the first number, 2 plus 2 times. Let's cancel its rows and columns. Cancel the row and cancel the column. So we are left with 1, 2, 2, 1. Take the next number, minus 1. Cancel its rows and columns. We are left with 3, 2, 2, 1. So 3, 2, 2, 1. Take the next number, plus 2. We cancel its rows and columns. We are left with 3, 1, 2, 2. Okay, so now we do our simplification. So this is a 2 by 2 matrix. So we do the normal method. So 1 times 1 minus 2 times 2 minus 1 into 1 times 3 minus 2 times 2 plus 2 into 2 times 3 minus 2 times 1. So now we simplify this. 1 minus 4, 3 minus 4, 6 minus 2. 1 minus 4 minus 3 minus 1 into minus 1 plus 2 into 4. So this is minus 6 plus 1 plus 8. So minus 6 plus 1 is minus 5 plus 8. So this is 3. So the determinant of the matrix A is 3. So that is our A part of the question. Now the B part says we should find the inverse of the matrix, hence or otherwise solve the system of equations. So first I will find the inverse of the matrix A. So this is B. Now I want to find the inverse of the matrix A. The first thing, I will write down my formula. A inverse is equal to 1 on the determinant of A, which we just did above, times the adjoint of A. Okay, this is the formula. Now we know the determinant, but we don't know the adjoint. So that is the next thing we will do to find the adjoint of the matrix A. So I write the matrix A again. 2, 1, 2, 3, 1, 2, 2, 2, 1. Okay, so to find the adjoint, we will first look for our cofactor matrix. So the adjoint of A is the transpose of the cofactor matrix. So that is the adjoint. So first I'll find my cofactor matrix. So write our original matrix 4 times. Write it again. Write it the third time. Fourth time. 3, 1, 2, 2, 2, 1. So I've written it 4 times. Now I remove the exterior numbers. So I'll be left with 1, 2, 3, 1, 2, 1, 2, 2, 1, 2, 2, 1, and 1, 2, 3, 1. Okay, so now we group them 2 by 2 matrices. So this is a 2 by 2. This is one 2 by 2 matrix. This is another. This is another, and so on. So we group them 2 by 2 matrices and find the determinants. So let's take the first 2 by 2 matrix. So the determinant here is 1 times 1 minus 2 times 2. We write it down. We take the next 2 by 2 matrix, which is this one. The determinant there is 2 times 2 minus 1 times 3. We write it down. We take the third. The determinant here is 2 times 3 minus 2 times 1. We write it down. Now we take the next 2 by 2, which is this one. The determinant here is 2 times 2 minus 1 times 1. We write it down. So here I'm taking them according to their positions. So I'm not putting them in this order. Another 2 by 2, 2 times 2 minus 2 times 1 minus 2 times 2. We take the next 2 times 1 minus 2 times 2 again. We go to the next 2 times 1 minus 2 times 1. We take the next 2, 3 times 2 minus 2 times 2. We go to the next 2 times 1 minus 3 times 1. And that is all. Now we simplify each one in order. So we take the first one, that is 1 minus 4, 4 minus 3, 6 minus 2, 4 minus 1, 2 minus 4, 2 minus 4, 2 minus 2, 6 minus 4, and 2 minus 3. Now we simplify again. So this is minus 3, 1, 4, 3, minus 2, 0, 2, and minus 1. So this is our cofactor matrix. Okay, so now we take the transpose from this our formula. The adjoint is the transpose of the cofactor matrix. So we have our cofactor matrix. So we take the transpose. So our adjoint of A is the transpose of that matrix. So it is a transpose. So let's do it. The row becomes the column. So the first row becomes the first column. That is minus 3, 1, 4. The second row this becomes the second column. 3 minus 2 minus 2. And the third row becomes the third column. 0, 2 minus 1. So this is our adjoint of A. Now we go back to the question, find the inverse. So A inverse is 1 on the determinant, which was 3. The determinant was 3. So write it down. 1 on 3 times the adjoint, which is this. Now that is the inverse. But that is not all for the question. The question did not end there. It says hence or otherwise solve the system of equations that. So let me write back the system of equations. So we have 2x plus y plus 2z equal to 3. 3x plus y plus 2z equal to 3. And 2x plus 2y plus z equal to 2. So the first thing when given a system of equations, you write it in matrix form. So we have 2, 1, 2, 3, 1, 2, 2, 2, 1. Now times our unknowns x, y, and z equal to 3, 3, 2. So this is it written in matrix form. So here we are interested in x, y, and z. We have to find x, y, and z. So to find x, y, and z, we will have to take the inverse of this matrix. We will have to take the inverse of this matrix times this 3, 3, 2. But we already know the inverse of that matrix. This is it. So it will make things easier. So it's just 1/3 into so that is the inverse. Now times 3, 3, 2. So I'll multiply this first before I include the 1/3, not to make things confusing. So we have 1/3 now. Now let's multiply row by column. Minus 3 times 3 plus 3 times 3 plus 0 times 2. 1 times 3 plus 3 times minus 2 plus 2 times 2. 3 times 4 plus 3 times minus 2 plus 2 times minus 1. Now let's simplify it. 1/3 into, so this is minus 9 plus 9 plus 0. 3 minus 6 plus 4 and 12 minus 6 minus 2. So we simplify it further. So minus 9 plus 9. 3 minus 6 is minus 3 plus 4. 12 minus 6 is 6 minus 2. We simplify again. 1/3 into, so minus 9 plus 9 is 0. Minus 3 plus 4 is 1. And 6 minus 2 is 4. X, Y, and Z. But we should not forget our 1/3, so we can multiply it now. So we have 0, 1/3, and 4 on 3. So we can conclude that our x is equal to 0, y is equal to 1/3, and z is equal to 4 on 3. And that is all for the question. So thanks for watching this video, and I'll see you guys in the next video.